it seems I caused some commotion by suggesting that natural units in physics and involving natural units in dealing with general relativity and those equations is somehow spurious and wrong and leads to philosophical issues. That's still what I believe, and I've had lots of comments back. And instead of replying to each of those comments individually, I thought I'd just do another video on it. And I think one thing that stood out in the comments is you can select some units of measurement such that C and G are both equal to 1, since they're both measured in different units of measurement, of course. The speed of light is measured in meters per second, the Newton's gravitational constant is measured in Newton meters per kilogram, and I had a problem with this, and it's more of a philosophical problem than it is anything else, and it's more a problem of equating length with mass and all these sorts of different ideas, whereas length and mass are not equatable. I don't think. You can have situations in physics where you've got an incredibly long object where the mass is really rather diffuse. You can have very compact objects such as neutron stars where the mass per unit volume is incredible but their length isn't necessarily so great, right? And you can have all this variance in nature in length and mass is being compacted into very small volumes, and length is by no means related particularly to the mass of something, and taking these constants C equals to G, you're doing something it's not just a mathematical issue, it's also a philosophical issue as well. There's something more deeply and fundamentally at odds with doing that. There's something deeper that's wrong there. It's something more like you're trying to take the ideas of weight and length, or the ideas of mass and length rather, and conflate the two, which is what David Tong really openly admits in his lecture notes. It seems absurd, really, to me. I mean, you can have a kilogram of flour contained within a bag. Does its mass have any bearing on its length? I guess not really. I mean, if you think about it, you can take the bag of flour, you can distribute it over basically any length scale you want. You still have the same mass of flour. You still have the same mass of the object in question. There's no relationship particularly between mass and length. Well, there is one, I guess, but it's really sort of arbitrary. And that's the point of it. Yeah, that's what it seems to me. It seems to me that this G equals to C equals to 1 stuff, this natural unit stuff, is arbitrariness in physics. It just comes down to well, we can just say it's this. Well, no, we can't, not really. I mean, not if you want to really understand physical reality and how it works. And then we're getting into abstruseness, mathematical land. Again, the point is the same. I'm sorry, it doesn't change particularly my argument. And I would just say it's equal to this and on with the maths. And showing mathematical relationships and consistencies between different sorts of equations. I'm not necessarily attacking things like ADS-CFT correspondence and things like this. I'm sure an anti-de Sitter space, there is a correspondence between conformal field theories and anti-de Sitter spaces. I know I have a middling sketch of what both those concepts in mathematical physics amount to, I think. But from a philosophical perspective, yeah, fine, okay, have that. How does that pertain to the physical world? What is really going on there in terms of protons, neutrons, electrons? There's a wave function of an electron, say. Okay, break that down. How does the wave-particle duality break down? Is it that an electron exists as a point particle in a different place, jumps around lots, and it seems to be a wave? Okay, I can sort of accept that for a free electron, say. But back to using, natural units don't just pop up in general relativity, they pop up in quantum theory and quantum field theory and all these other places where we set h bar equals to 1 or h equals to 1 as well, and other things like this. What you're doing is you're doing something more deeply and fundamentally wrong than merely conflating two numbers, two dimensionless quantities, which you're doing something more fundamentally wrong than just conflating two numbers which have different dimensions associated with them, have different units associated with them. It's worse than that even. You're just saying the units don't matter. Any physicist, any real physicist should hate that idea. Should hate the idea of what units don't matter in physics. Surely the units are everything, almost. That's what we're studying. We're trying to do calculations, we're trying to invoke mathematics to get physical quantities out of something. If we don't know what we're measuring, if we don't know the units of something, suddenly, like, we've stopped doing physics. That's the point. Like natural units, like you're not even invoking units as such. There are no units. We suddenly start dealing with dimensionless quantities, and then we're off into whatever, aren't we? And we can say whatever we want, basically, as long as your maths is sophisticated enough. As long as you've got enough symbols in everything, and you stop dealing in Newton meters squared, or whatever, or foot pounds, or or meters, or inches, or whatever. You see, or coulombs, or whatever it is, and you start dealing with something more abstruse, something uncoupled from reality. And that video generated 4 dislikes, and it got 1 like. And I can see the dislikes, and no one else can. So it almost makes you think, like, so snipey of, like, clearly physics people descending upon it. And I got something bad to say about physics, but yeah, like, I do have something bad to say about physics. It is nonsensical. It doesn't correspond to sense impressions, what we can see in observations, what we can see in measurements. It ultimately needs to come down to something, yes, you can measure in units. And the conflation is worse than just putting 2 non-identical numbers together, throwing away the units entirely. Like, the kilogram is not the meter, if you see what I mean. It's not the meter per second. Like, it's a bit more different between merely length and weight as well, or length and mass, sorry. Weight and fucking mass, but it's more like meters per second, so it's meters over time, or distance over time, of course. So you've got this time element in it, but you're equating time now with mass on a level, or the meter per second, or speed with mass, if you see what I mean, or speed with the force generated by a kilogram of mass in space, the Newton meters per kilogram. Is very, very fishy, is what it is. And just think, let it equal the same. No, they're not the same, not at all. They're not at all the same. Even Einstein, I don't think, was he going around doing that? Was he just saying, let it all equal to 1? Or was he eventually getting quantities out of it that could be measured in newtons or pascals or whatever from the general relativity equations? As I understand it, I think he was. And where did this signing convention come in, or this, not signing convention, but like this convention actually come from? Who started it? I know that had no place in 19th century physics. I don't think. I think that was very much a 20th century move. That very much originated with quantum theory and general relativity. I don't think I've ever encountered anything in classical mechanics where you get rid of the dimensions and the units, or you conflate the dimensions, or it's like get rid of the units entirely. It angers me. It's wrong for some reason. It's deeply, fundamentally, philosophically flawed. There's a deep illogic to it. And it's slapdash, it's piss poor. Yeah, and I know that it's all like physics undergraduates watching these videos, or watching that video in particular. Going, no, it's like this, because they've all learned it like that. They've all gotten good grades for it now. They've got a degree in physics or whatever. And yet, like, maybe on a level you're resenting your educations. I resent it as well. But, you're being led down a rabbit hole by people who, in their turn, have been led down a rabbit hole. To say the same thing over and over again, and to spew the same claptrap from, in front of a blackboard, when you get to be a professor or whatever. No, it robs it of physicality. It robs it of physical meaning. It doesn't allow for us to be able to interpret what's really going on in a system. We're just awaying the harmonious and beautiful, very beautiful, albeit extraordinarily beautiful realm of differential geometry and topologies and abstract algebras and all this wonderful, beautiful, harmonious mathematical stuff that represents an abstract, idealized sort of continuum of some sort of possible reality, maybe. It doesn't correspond to what the real world is, though. That's the thing about maths. That's the sharp edge on which mathematics and physics depart from one another. You can talk about, endlessly, like, de Sitter, anti-de Sitter spaces and Calabi-Yau manifolds on those spaces and whatnot and all this sort of thing. But where is the predictive power of those sorts of things? Where do those sorts of things manifest in reality? How do we test for them? How do we observe them? And crucially, if we're going to make an observation of something, what we need to get out of those considerations is, things like what the temperature of something is going to be, what the frequency of a light ray bouncing off something is going to be in hertz, or what have you. And it comes down to ultimately things like the interactions of photons off things. Well, it largely comes down to that if you're reading temperatures or frequency. I mean, any sort of given light ray has a given ability to impart a temperature to something, so it sort of goes together that way. But force of gravity conflated with conflated with meters per second. So either I'm missing something deep about general relativity, and really those two things are deeply interconnected, but the constants associated with them, they seem to be diametrically opposed, it seems to me. The speed of light doesn't vary at all, ever, even when you are approaching a black hole. I mean, the lengths over which something is travelling, maybe the speed of light does vary. Maybe it does vary when you get very close to a black hole. I'm just sort of spitballing now, really. Because we think of like length contraction as it just space-time shrinking a very long length down into a very small area. So the photon still travels the same distance. What am I probing for now? There is something at the bottom of this, and this connects to the theory of quantum gravity that I work on. What if Einstein was wrong about that? And there is no length contraction near a black hole, and it's something else? What if it's an electron density surrounding a black hole? Then, like, strictly speaking, in classical terms, in classical physics terms, there is no length contraction. Do you see what I mean? If you take the distance from the event horizon to, say, somewhere way beyond the firewall, like a few light years beyond the firewall, in classical physics terms, the photon is just getting to the event horizon over the same distance. It's just getting there a lot more slowly. Yeah, the relativity, general relativity, on important levels, on crucial levels, might be total bunk. Maybe I figured that out, and it's another eureka moment for myself. And there's natural units stuff is like, maybe well introduced by Einstein. Maybe Einstein was talking out of his sideways crack, so to speak. And he was cracked originally. And an idiot. Yeah, like classically, for these dark stars, so-called, according to Hubble, who called them dark stars, relativity might be totally incorrect. On a level it isn't incorrect. Well, that's the other thing. Of course, it's not totally incorrect. But length contraction in black holes is not length contraction, it's time contraction. Or time expansion. I.e., it's the light ray, the photon approaching the black hole, slowing the fuck down. Because it's got to go through all this mass of tunneling electrons, this huge firewall of other photons trapped there. There's a fundamental problem with the theory of general relativity. This is what's been leading to all this trouble with gravity and the Standard Model. And it's this sort of thing, I promise you. I know it's other physicists watching this video, so you're well disposed to watch this and to think about it. And yes, to take issue with things like C equals G equals 1, and for that matter, general relativity itself. And to not just question, and to not just accept what you've been taught, to question it. To question whether or not this beautiful mathematics, these Ricci scalar curvature tensors and these Riemann tensors and these Riemann geometries, and stress energy tensors and all this other stuff, tensors and matrices and all this beautiful mathematics, whether or not it could all be bunk, whether important elements of it could be bunkum. Ganz Falschness, in the words of Wolfgang Pauli. Totally wrong. Yeah, well, no length contraction, or length contraction not being what we think it is. That, I submit, is closer to being the right answer. Yeah, I think so. I was still right about natural units nonsense.